This is the X-59, NASA and Lockheed Martin's vision for the future of supersonic flight. It's in the final stages of building now, but when it finally takes to the skies, this aircraft right here could change the sight and sound of aviation forever. The team behind the X-59 wants to do the seemingly impossible: fly an aircraft that breaks the sound barrier without creating an explosive sonic boom for everyone on the ground below. And NASA and Lockheed Martin have given us exclusive access for the very first look at this aircraft to find out how it works. Supersonic passenger travel has the power to revolutionise the aviation industry. The promise of shooting through the skies at 1,000 miles per hour, faster than the speed of sound. Breakfast in Paris, dinner in New York. But the reality has never quite been able to keep up with that dream.
There she goes. A big moment through the sound barrier. The first time.
When Chuck Yeager broke the sound barrier in 1947, that launched a generation of X-planes, experimental aircraft designed to break through the bounds of aviation. One of those is behind me, the X-1E, one of the first planes to break through the sound barrier. But that high speed came at a high cost with the sonic boom. In the early days of aviation, the only people that could experience supersonic flight were military test pilots. But by the late 1960s, supersonic travel broke into the mainstream and finally came within reach of civilian passengers. And at the forefront was Concorde.
The Concorde, first commercial supersonic transport, has its public debut at Toulouse in southern France.
A joint effort between British Airways and Air France, the Concorde flew up to 100 passengers and had a cruising speed of Mach 2, twice the speed of sound.
The end of the runway is Concorde 001.
Suddenly, anyone could fly at supersonic speeds.
Nose come up to 20 degrees, she's airborne.
By the mid-90s, a round trip from JFK to Heathrow cost around $8,000, or the equivalent of about $15,000 today. But while the Concorde commercialised supersonic flight, it also brought that sonic boom.
The prospect was you would have planes flying supersonically every day over your home and breaking the sound barrier all day, all night.
In 1973, the Federal Aviation Administration issued an order banning supersonic flight over land.
Because it could only operate in certain places, that limited a number of routes, that limited how much money it could make, and ultimately the airlines realized this is just too expensive to operate.
In October 2003, the Concorde was retired for good. The sonic boom has been holding back supersonic passenger flight ever since. But NASA wants to change that. Here at the Armstrong Flight Research Centre, NASA has been researching supersonic flight for decades. Now it's on a new quest for quiet supersonic technology. It's recruited Lockheed Martin to build a brand new low-boom aircraft using breakthroughs in aeronautic design, material science and computational modelling. A supersonic plane so sleek, so cutting edge, that when it flies, the sonic boom becomes a sonic thump. To understand how NASA and Lockheed are reshaping flight, it's worth knowing a little bit about the science of sound. Sound waves are essentially waves of compressed air that move through space, kind of like a pulse in a slinky, travelling from the source at a speed of roughly 340 metres per second. But when a supersonic jet flies faster than the speed of sound, what's known as breaking the sound barrier, it's moving faster than the compressed air can move out of the way. Think of it like a boat travelling through the water. The waves build up and move out in a V-shaped wake. It's the same for a supersonic jet, but in 3 dimensions. Instead of sound waves moving out in front of the aircraft, they're forced together, producing shock waves that travel behind the aircraft in a cone, and that's what we hear on the ground as a sonic boom. People on the ground only hear that boom when a supersonic plane flies above them, but that sound is actually constant. A sonic boom measures more than 100 decibels. That's about as loud as a fireworks display. And if a supersonic plane was flying over the United States, that noise would be heard by everyone underneath the path of the aircraft. To minimise those shockwaves on the ground, you need to change the shape of the plane and make it far more streamlined. Any big variation in shape, like a cockpit jutting up at the front, can produce a shockwave. The idea is to smooth out those variations, which reduces the shockwaves, and then spread them out across the body of the plane. At just under 100 feet long, the X-59 is shorter than the Concorde, but more streamlined and with a much longer nose. The wings are swept back to reduce drag, and there's no canopy sticking up at the front of the plane for the cockpit. Each of those design points helps spread out and separate the shockwaves produced by the aircraft, which in turn reduces the sonic boom. The hope is to cut that boom from the 105 decibels produced by the Concorde down to 75 decibels. According to NASA, that's equivalent to the sound of a car door slamming down the street.
The X-59, if you look at it and notice, it's a very long airplane. It's nearly 100 feet long just to carry one person. And so that's what we're doing. We're dragging out, if you will, those volume changes, making them very gradual across the entire body of the airplane.
As the company contracted with building the X-59 for NASA, Lockheed Martin was tasked with designing, building and iterating this new low-boom supersonic aircraft. But unlike the 60s, when designing a new plane meant building and testing scale models in wind tunnels, Lockheed can use something called computational fluid dynamics, essentially getting a computer to simulate different designs and the kind of shockwaves they would produce.
The physics have been around forever. It's just being able to model those effectively. And with the advent of fast computers, you could iterate very quickly between the geometry and then analyze that in the computer to learn, well, what does this geometry do to help us to reduce those shocks and stretch those out to make the boom quieter.
After years of iteration, the X-59 is in the final stages of its build in Palmdale, California, at Lockheed Martin's Skunk Works division. Inside this high-security facility, the company designs and builds breakthrough aviation technologies, most of which we can't actually see because they're classified. But we've been given unprecedented access to see the X-59 as the final assembly takes place.
So I'm actually inside the body of the X-59 right now, something I never thought I'd say. And I have to say, inside here, you can really appreciate how long and narrow this airplane is. It's about 2 body widths wide, and it's amazing to be inside an experimental aircraft. I never thought I'd get to see something like this so close and personal.
Just like birds are just perfectly designed, this airplane is being perfectly designed to fly supersonic as quiet as it can. And so these are not things that basically, a computer or man would say, this is what it should be. This is what Mother Nature is saying, no, this is what I want.
So what you can see behind me, you might think of an airplane wing as being fairly straight and flat, but if you look down here, you can see it kind of looks like a bird. It's a gull wing design, and that is designed to make the air flow smoothly over the aircraft, once again, so we don't hear those shockwaves that become the sonic boom.
While the outer shape of this aircraft is cutting edge, the actual body is made up of parts that are already used in other planes. Landing gear from an F-16, a cockpit and ejector seat from a T-38 jet. But there is one new feature on the inside that sets the X-59 apart. Because Lockheed wanted to minimise big changes in air pressure, it had to do away with the large cockpit windows sticking up at the front of the plane. In fact, there's no front window at all. Instead, the X-59 has an external vision system, or XVS, designed and built by NASA. The XVS uses 2 cameras above and below the aircraft to create a real-time view of the front of the plane shown on an HD screen. Sensors across the aircraft also feed in data, meaning the screen doubles as a heads-up display for the pilot. For NASA test pilot Nils Larsen, that high-tech display brings advantages over a traditional cockpit window.
Essentially, it's very much like a heads-up display that you would see in a fighter aircraft. So you have your airspeed on the left-hand side, you have your altitude on the right-hand side. I can see the, the horizon. I have a flight path vector or marker that I can move and put on the horizon, which makes it a lot easier to fly. It actually gives us sometimes more capability than you might have if it was just a window.
Back at Lockheed, the team is in the final stages of the build, which involves installing electrical systems, connecting the tail and that incredibly long nose to the main body of the plane, and getting the aircraft ready to fly. But assembling the aircraft is only half the story. Once the X-59 is built, it needs to go through 3 phases of testing. After Lockheed runs its initial test flights in Phase 1 to make sure the plane can actually fly, it'll hand over the keys to NASA for Phase 2, acoustic testing, and that's where things get really cool. NASA will send up an F-15 jet to fly around the X-59 and measure the shockwaves produced in the air. The idea is to make sure they're behaving as expected. Then it's going to photograph the X-59 mid-flight and capture what's known as a Schlieren image, showing the actual shockwaves around the plane. Photographing a plane going faster than the speed of sound? That takes skill.
The X-59 airplane has to eclipse the sun, if you will, because we use the sun as a backdrop for our Schlieren photography, and all of that has to happen perfectly. It's like threading a needle to get that gorgeous image.
Then NASA needs to measure the sonic thump at ground level, but because the plane is travelling so fast, that sound could be spread across an area up to 50 nautical miles wide. So, NASA is setting up an array of microphones with 70 sensors spread across 30 nautical miles. That way, they'll be able to measure the volume of the sonic thump from the plane flying 60,000 feet overhead. After all that acoustic testing comes Phase 3, when NASA will fly the X-59 above a handful of communities, both in busy cities and quiet rural areas, to see how people actually respond to the noise. NASA is going to present all this data to regulators with the goal of lifting the 1973 ban on commercial supersonic flight. After all, back in the 70s, noise was the problem. But if NASA can prove that supersonic planes can fly without the boom, then speed shouldn't matter. This could open the door to a whole new generation of supersonic flight, and there are plenty of companies waiting in the wings ready to take advantage. Companies like Exosonic, which has won a contract with the US Air Force to develop a low-boom supersonic executive transport. Imagine a future where Air Force One could go supersonic. And then there's Boom Supersonic, which has partnered with United Airlines and is working towards transatlantic and transpacific flights by 2029. With so much happening in this space, supersonic passenger flights could be closer than we think. For now, NASA and Lockheed Martin are focusing on getting their one and only demonstrator aircraft into the skies. And after decades of research and years of design and development, that first X-59 flight is going to be a huge milestone.
I wish that everyone could experience a first flight because it is one of the most emotional things that you go through. And it is really what makes this job and all the heartache and the stress worth it, is when you see that airplane fly. There's a very personal sense of accomplishment, but also for an airplane nut like me, it's emotional.
As a test pilot, this is what you live for. This is an X-plane, and this is research, and there's the cool factor just to us is, this is why I became a test pilot, is to go and do something like this. So, am I excited? You betcha.